This is going to be question number 5 on the discussion that we didn't go over. And so it's going to be called remove. And so what's going to happen here is that we're going to have a list, an item, and we're going to remove all occurrences of that item from the list. And so one example right here, the doc test at the very bottom is, let's say we want to remove the number 3 from the list, like 1337. And so as you can see, kind of intuitive, the return result is going to be the list without all the 3's. So cross out the 3 right here, 3 right there. We're going to get like 1, 7 at the very end. And so, yeah, I feel like you've done this already in Python. It should be fairly simple to like write in Python, but the issue here is like, how do we convert it to scheme? And so we can first start off with like what the hint says, and then we can go into like the approach where you don't use any like built-in functions. And so starting off, let's take a look at what the filter function does. So filter is going to take in a predicate in the list. And so remember from Python that a predicate is going to be like a one argument procedure. So it's going to be a function. And in scheme, you can define a function via either like define or lambda. And then so this predicate is going to return true, basically if you want to include it in the list, and then false if you want to exclude it. And the list is going to be like a scheme list that you want to provide, and it's going to apply the predicate on each of the elements. And for the elements that the predicate returns true, it's going to keep those elements, and it's going to exclude all the other ones. But yeah, take a minute or two, like think about how you can use the filter function. Should be pretty similar to how you used it in Python. And then we'll go over how to apply it in this function. All right, let's get started. And so if we think about it, filter pretty much accomplishes what we want to do with the list. And so for the list, we have like a certain condition, right, of whether we want to include an element or we want to exclude an element. And so the condition is whether that element is equal to the item. And so if it's equal to the item, then we want to like exclude it, right? So to exclude it, we need to return false. So the condition is if it's equal to the item, we want to return false. Otherwise, we want to return true for our predicate. And so since filter does pretty much what we want to do to our list, we can like write this right here. Filter some predicate from our list. And remember that predicate is going to be a function, takes in one argument. In this case, it's going to be an element. For example, if we had like the list 1 through 37, the first element would be 1. We apply predicate on 1, then 3, then 3, then 7. And then we expect the predicate to like return true for 1 because we want to include the list. Same with 7, but for 3, we wanted to return false because we want to exclude it. And so how are we going to define our function? There are like 2 ways of defining it, but the way I'm going to go about doing it here is with a lambda. And so lambda, remember that lambda and defines are like pretty much the same thing. Actually, in this case, you can't really use the define since with like without some additional logic, because define won't return a function, but a lambda will, and you need to supply a lambda to the filter function, because define will only return the name of the function. And so what we're going to do here is we're going to define a lambda function with one parameter x, or we could call it element, el. And then what it's going to do is there's a conditionality we want to check, right? If it's equal to the item in the list. And then so one thing to note about this problem is that all of the elements are numbers. And so since they're numbers, we want to be using like the equals operator to be comparing like 2 elements, the element and the item. And so what we can do here is we can have an if condition. So if those 2 items are equal, so if the element and the item are equal, then what do we want to do? So in the case of remove 3 from the list 1 through 37, let's say we passed in the number 3, and the current element is 3. And so 3, we want to remove it, and 3 is equal to 3, so we're going to return false right there, saying we don't want to include it in that list. So hashtag f, and otherwise we want to return true. And one thing to note is that you could return true, you could return 0, you could return nil. All of those evaluate the truth values, and so either way, all of those are going to be included in the list. And so yeah, that's going to be our lambda function that we're going to be filtering out from the list. And then yeah, let's check if this works real quick. I might have messed up, who knows. Okay, cool. All right, it worked, nice. But yeah, so this function, the predicate, basically told us, do we want to include this element? Do we want to exclude this element? And it's like, if this element is equal to the item that we want to remove, we're going to exclude it. Otherwise, we include it. And yeah. And so that was the way to use the filter function to solve this problem. But let's try doing it like the more standard way. And so the more standard way is the way we like typically are going to go about like solving scheme problems, and that's by like using recursion. And so if we like think about how we used how we solved like the problem with the map, basically what we did was we went through here, I'll like write it down here actually. We went through like each element of the list. So in this case, we went like 1, then 3, then 3, then 7. And then actually, let's consider recursion like one step at a time. So we consider like the first element, the 1. And then we want to decide whether to include it or not. And then what we do is we make a recursive call on the rest of the list. So on the 3, 3, 7. And we should expect it based on recursion to like filter out the 3s for us. And so we expect it to like return 7. And then we're gonna like do stuff with that additional 1. And so this is like the pretty standard way of like approaching scheme problems and recursion. And it's like similar to how you did like linked lists in Python. And so let's think about like two cases. And so, this recursive call right here on the rest got us like just the list 7. And then we need to decide, do we want to include this one or do we want to exclude this one? And so in this case, since 1 is not 3, the element that we want to remove, we're going to like add it in, right? So if we want to add to the 1 to the beginning of the list, we're going to go like cons 1 to that list 7. And that's going to get our answer of like 1, 7, which is what we want. But let's say that our list is actually 3, 3, 3, 7, right? And our recursive call on the rest is going to give us like the list 7. And we need to decide, do we want to include this 3 or do we not? And then, so you can see here that, 3 is equal to 3. And so that's an item that we want to remove from the list. So we shouldn't add it back to that list right here. And so what does that mean? That means that our final result should just be the list 7, which is what we got from the recursive call. So we can just return it as is. And so there are like two cases right here. I'll like write recursive calls right here. And then one is if the car is equal to the item. So if it's equal to the item that we want to remove, then you want to exclude it. So it corresponds to the situation right here. And we're going to return only the recursive call. So that's like the recursive call on the cooter of the list. So like the rest of the list was just like 3, 3, 7. Yeah. And then the other situation is if it's not equal to the item. So if it's the item that we want to include in the list, so if car, I'll just say like otherwise right here, else. I just realized you can't see this because my face is blocking the way. But, all right. Let me remove my face from here. All right. Otherwise, our second scenario is that otherwise we want to like add that element, the car of the list, to our recursive call. So that's corresponding to the situation above here. So we want to add that one back to the list 7. And so what we're going to do is we're going to be consing that first element, so the car of that list, back into our recursive call. And that's going to be, our function is called remove. And so it's going to be removing that item from the rest of the list. So CDR of the list. And you can imagine that it's going to take care of like, the recursive call is going to take care of removing the 3 from everywhere. And we can just decide whether to add that first element back in or not. And so yeah, that's going to be our recursive call. And then last but not least, let's consider our base case. So I'll like write it up here. So our base case is going to be like the most simplest case in which we know like whatever we want to return. And so our list 1, 3, 3, 7, we make a recursive call to like 3, 3, 7, then 3, 7, then 7, then an empty list. And the question is, where do we stop here? Where do we know like directly know the answer? And so same as usual, our base case is when we reach like an empty list. And so when we reach an empty list, there are no items left to remove. And so we can just return the list as is, as an empty list. And if you can imagine, like going back of the recursive calls, we're going to add the elements back one at a time. So we're going to add the 7, then we're not going to add the 3s because we don't want to include them. Then at the very end, we're going to add that 1 back in, and we're going to get like 1, 7. Yeah, so our base case is going to be if the list is null. So if the list is null, then we want to return like an empty list. And we're going to return the list because it's the same thing as the empty list. You can return list right here, or you can also return nil or empty list. They're all the same thing. But yeah, let's go about coding our function here then. And if you wanted some practice with like coding this game, feel free to like pause the video, take a minute or two, or like however much time you need. And yeah. All right, let's get started. And so starting off, let's like start with our base case first, because I usually like to put my base case first, because yeah, that's what you like usually do. And so our condition right here is if our list is null. Actually, if you think about it, we have like 3 conditions right here. So we first want to check if our base case, if we reach our base case, and then we want to check is it an element that we want to include. And then afterwards, we have like another condition if it is an element and if it isn't. And so since we have 3 conditions, it is a bit cleaner to use a cond rather than an if. You can use like nested ifs, but I like cons, so let's like do it this way. So cond, and remember that how it's going to work is that for each condition and return value, we're going to have like parentheses around it. And so it would be like condition, then return value. And so our first condition is if the list is empty. And so if null a list, what do we want to return? We want to return an empty list. And I'll like put nil right here. You could put list. You could also put like quoted parentheses. All are the same. All are okay. I'm going to go with maybe nil. So an empty list. Yeah, and then afterwards, we want to check if the item is equal to the first item in the list. And so we need to decide, should we include this item or should we not? And so our condition is if the item is equal to the first element of the list. So if is item that we want to remove, an element that we want to remove, then all we need to do, as mentioned before, is if car is equals item, we're just going to return a recursive call, because the recursive call is going to give all the other elements, and there's no point in adding that element back because we don't want to include it. And then so our recursive call is going to be remove item from that list, from the rest of the list, so like the CDR of that list. And then last but not least, we need an else statement. And so the else condition is going to handle if the item is not equal to the first element of the list. So if it's not equal to the first element of the list, then we want to include it. And so I'm just going to copy over what I have down here. Right here. I'm highlighting it right now. But what we're going to do is we're going to add that first element back to the recursive call. So cons of the car of the list. Remember that cons is the first element. The first parameter is going to be the element that we want to add back. And then the recursive call is going to be the list that we're adding it to. And so remove item of the recruiter of the list. And yeah. And that should be it. And just as an overview of like what's happening here is, so I'm going to go over the same example. So the list 3 and then 1, 3, 3, 7. So what's going to happen here is we're essentially, let's see. So we see the 1 right here, and we see that it's equal to, not equal to 3. So this is an element that we want to include, and we're going to be making a recursive call to the 3, 3, 7. And we see the first element, that's a 3. That's an element that we want to exclude, and let's move on. So now we're dealing with 3, 7. 3's and, oh, let me put X's around rather than circles. So 3 is the element, once again, that we want to exclude, and then we move on to 7. We want to include the 7, and then finally we use our base case where it's an empty list, and we're going to return an empty list. And it's going to go back up like the recursive calls. And so we're going to be consing that element, 7, back to the empty list. So going up, we get the list 7. And going up, we don't add that 3 because, we hit this condition right here. or we just make a recursive call, and then we go back up, we don't include that 3, and then we hit the 1, we're going to add 1 to that list 7, and we're going to get 1, 7, and that's going to be our final answer. Yeah, hopefully that made sense. If you have any questions, feel free to like email me. But yeah, I'll see you next Wednesday. How do I close this? Fuck.